Welcome in, everyone. We're at the beginning of week 10. This is going to be a pretty sweet lesson, actually. We're finally going to be able to branch off into different parts of the program. Lately, we've been just writing flat programs that can't really make any decisions. Right, so I want to introduce something called decisions and branching. Right, this is actually going to bring us back from week 2. On week 2, we covered some Boolean operations. For a quick refresher, here's the week 2 stuff. You might remember we covered a operations that returns true or false. These last 5, they're not performing really arithmetic. They're doing comparisons that are returning true or false. We haven't used these results yet. Today we'll finally do that. These are conditions that allow us to branch into different parts of the program. So just for a quick recap, right, the prereq for today is to understand how to write conditions. Right, just as a quick little recap on Boolean conditions. Let's see, I'm just gonna hard code a variable here. I'm just gonna say age is equal to like 29, right? I wanna bring up the difference between an assignment operator and an equality operator. Right, so this single equal sign is assigning the right value to the left variable. Right, it's not comparing for equality. When we do compare for equality, it's with a double equals. So if we say, is age equal to 29, right, this is comparing, which will return true, right, because both are equal. And if I change the right side to like 30, right, this gives us false because they're not equal. And there's a couple other conditions that we covered too, right, like less than or greater than, right? Is age greater than 21? Yes, that's true. Once again, we haven't used these results yet, but today we finally will. Okay, but I do want to reiterate a pitfall between the single equals and the double equals. Right? But basically, you don't want to compare for equality with the single equals because that's assigning the right to the left. Okay. As a quick sneak peek into today, these are just numbers, but we can do stuff with strings as well. Like, let's say we're working with a voice assistant. Voice assistant like Siri, right? For folks who have an iPhone, or maybe you have a Google Home where you can control the light bulbs in your house. Right, so let's say there's a voice command. I'm just gonna hard code a string here real quick. Like let's say you're commanding a voice assistant to turn on light. Right, so I'm just gonna hard code a string. We can write conditions that represent what's available in a command. For example, we can say, hey, is turn off, right? Is this string in the voice command? Right? This is a condition that returns false. Right? It's false, but if we say turn on, welcome in, Terrace. But we say turn on here, it's going to return true. Right? So we can use these results to branch off into different scenarios, which brings us to decision trees. So a decision tree is a way of representing certain outcomes. So we can write conditions that branch off into different scenarios. Like here we see just speaking generally right now, right? The root node, this is the first decision. And if that decision is true or false, we're going to branch off into sub-trees, right? That asks other questions. So just to make this a little more concrete, an example of a decision tree from 2019 or 2020 is a COVID decision tree. Oh, do you want to stay home? Do you want to get tested or call a doctor? Uh, this decision tree right here kind of represents the conditions, right? Like on the top root, the first condition is, are you having any symptoms? Right? No. If it's no, then testing is not needed. Then if you have been in close contact, then stay at home, right? If you do have symptoms, then there's a subtree here, right? Are the symptoms severe? If it's a yes, then call the doctor, right? If it's a no, then it's gonna go into another subtree. This decision tree was actually used at UCSC a few years ago. Basically, UCSC had folks download an app, and before they entered campus, they would have to load the app and answer some questions. Basically, every day before you got on campus, you'd have to answer 2 or 3 questions, and it would be just these 3 questions here. So something like this. Right, so this decision tree was used in an application to allow entry. Another example of a decision tree that we might represent. Some folks are interested in AI. I spoke to a few folks here. They said they wanted to get into game AI. So uh, let's talk about Pong, right? How would we write a decision tree to represent a computer beating a player? Right? Like let's say the computer is on top and an actual player is on bottom. Right? How would you write a decision tree to beat the player? You could represent it. You could just follow the ball. Right? Is the ball left of the paddle? If yes, then move paddle left. Right? If it's no, then check if it's right of the paddle. And so this decision tree is really just following the ball. Okay. Another example of a decision tree would be whether or not to approve a credit. Right? There's some folks might have done pre-approvals on credit cards. Right? Pre-approvals usually consist of a decision tree. Right? Pre-approval meaning that you're typing in some information, and then the company will tell us whether or not you can be approved. Right? It's going to look at your credit history, your income, and there's some other decisions to be made as well. But typically, the approvals use some sort of decision tree. Okay, so hopefully people are kind of getting the sense of this week's material. This week's material will be implementing conditions that allow us to branch off into different areas of the program. So let's do some syntax. Right? So we've talked about conditions. Conditions are something that's true or false. Right? And based off of that result, we'll branch off into different outcomes. So in Python, we can write some if statements. Right? But basically the syntax for an if statement goes, if some condition, right? Once again, condition is something that's resolved to true or false. Right? And then colon, and then we're going to do something. Right? And then we'll stumble upon some other branches as well, like else if. We'll talk about this halfway in the class, and then there's an else as well. Right? So let's talk about the if statement. So I'm just going to do a quick sneak peek. So once again, today's material, we're really just going to be on lesson 14 in lab 14. Before I even open these up, I'm just gonna open up a Scratchpad just so folks can get a sneak peek into the general if statements. So I'm just gonna create a sneak peek notebook. Let's see, let me call it decisions. Decisions. Okay. Let's see. Let's say we're writing a program that determines entry to a certain place, right? That relies on your age. So I'm just gonna hard code a birth year, right? Like I'm just gonna say birth year is equal to, I'm gonna hard code 1996. And let's say I'm trying to make a program that goes branches based off your age, right? So I'm gonna need to grab the age based off of this variable. Right, one way we can do it is just saying age is equal to 2025 minus birth year. Right, I'm not really too much of a fan of this though, because 2025 is hard coded, meaning that if we were to run this program in the future, it would be the same outcome. So it would probably be a better programming practice to not hard code this 2025, right, and maybe make a variable that represents the current year. So this current year variable doesn't exist yet. I'm going to go ahead and make it exist, current year. And once again, I'm not going to hard code the 2025 here. Right? I'm actually going to pull it from a Python library. Right? You don't have to know too much about this Python library, but there is a library called datetime that allows us to pull data from the clock. So I can set the current year to a function from this library, right? It's called datetime.now, and then this function has an attribute to it. It has a year attribute. So yeah, we're just not hard coding this. Okay, so I'm going to print out the age just to sanity check these variables. So I'm just going to sanity check the age variable. Okay, let me run this. So press play. Okay, cool. It looks like these variables are initialized correctly. Right? Current year becomes 2025, and birth year, I just hard coded it as 1996. All right. Let's implement an if statement. Let's say we were to branch off into different scenarios where we allow entry, right? Like let's say you got to be over 21 to get somewhere, right? Like let's say let's write a condition that represents whether or not we're old enough. So I'm gonna do an if, and then the syntax of it goes a condition, right? The condition is something that returns true or false. Right? So I'm gonna represent age is greater than 21, greater than or equal to actually. Right? Once again, this condition will return true or false. Right? If it's true, we're gonna enter in the body of this if statement. So let me just do a print statement, right? So print, let's see, I'm just gonna say like welcome in. Or let's see, welcome to the club. I think most clubs, yeah, are 21 and over. Exactly. So yeah, this condition should be true, meaning that we're going to print this statement. I'm going to press play, and it says, yeah, welcome to the club. Right, so there's our first scenario. And if I change this birth year, right, to something else, like maybe 2008, right, I don't think we're old enough, so there you go. I just press play and nothing printed, right, which makes sense because this condition is false. This condition is false, so we're not going to execute the body of this if statement. We need to represent the other branch as well. Right, there's so many different ways we can do this, but one of the first ways we'll see is an else statement. Right? Basically, an else captures everything that's not true. Right? So this is saying if the earlier branches were false, then we're going to execute the else body. So I'll print something like come back again. Come back again later. Okay, so I'll press play here, and yeah, it says come back again later, right? Which makes sense because this is false, so the else will capture we'll capture this. Okay, let me change it back to 1996. So birth year is 1996. There we go. Welcome to the club. Let's see, birth year is not defined. Let's see, did you set it equal to right here? Okay, birth year is not defined. It might be a typo. Here, let me see. Oh, okay. Yeah, just a little typo. Yeah, the variables have to be the name the same. Okay. This is just a small sneak peek. Right? All we did was program a tree that represents 2 branches. And we didn't hard code the year. So if folks put their birth year in here and it says come back again later, you can run this program in the future, and someday it might say welcome to the club if you're under 21. Okay, any questions about this small sneak peek before we jump into the lesson and lab? Yeah. Oh yeah, good question. How is this current year being processed? We You don't have to know about this library too much, but this library allows us to pull data from the clock. So we're using a function from this library called datetime_now, and then it has an attribute .year. If folks want to take a look at this library, you can look at this library. So I'm just going to Google up datetime in Python. It's going to bring us to documentation right here. This is the primary documentation, which will show us all of the available functions that we can access. There's a lot of different functions we can access, like a time zone. Right? We can access the zone that we're in. Let's see, what else? We can access seconds, days. Yeah, there's multiple things we can do. So yeah, feel free to take a look at this library, but it's not too important for this lesson. The only reason I imported this is so I didn't have to hard code a 2025 here. Because hard coding in 2025 here means our program is going to be the same every time we run it. Yeah, good question, Terrace. Yeah, date time. And I do use this library a lot. In my other classes, I use this library to tell whether or not an assignment is late. Right? I pretty much have a late policy in some classes where every day is a certain amount of percentage taken off. So this library allows me to kind of calculate the late policy. All right. Okay, let's jump into the material. Once again, we're going to be in lesson 14 and lab 14. Oh, good question. Someone asked, are these standard? Yeah, in most Python interpreters, these come natively. So this is not an external library. You don't have to download anything for it. Yeah, good question. Okay, so let's load up the lessons in lab. Let's see, lesson number 14. This is going to take 2 days to finish. So on Wednesday, we're going to finish this. We have a lab associated with this as well. So lab 14. Okay, I just opened up the lesson and the lab. We should be able to get through the first 2 parts in the lab. And then on Wednesday, we'll finish up part 3, where we're writing some functions. All right. So we're going to jump back and forth a bit. Let's cover a bit of the lesson 14 and then jump into an intermission for the lab. Okay, we saw a sneak peek on if statements. Basically, the if statement takes a condition, and if that condition is true, we're going to execute the body of the if statement. The indents do matter, by the way. You can use a tab or 4 spaces. Anything that's indented that's underneath the if statement, right, belongs to the body. So yeah, make sure everything is indented if you want it to be in that outcome. Okay, cool. Let's the first example we'll see is a number widget. You don't have to worry about the widgets too much here. The takeaway from here are if statements. So this block is going to display a number widget, and basically we're going to write we're going to write a tree that it's pretty much a guessing game, right? Like pick a number, right? And then if you pick the right number, it's going to say, oh, correct. Right? So for example, we can access the number widget's value with this attribute. Right? So this number widget is called number widget. We can access the value. Right? This is an attribute. So we can branch based off of this number. Right? Like let's say the correct number is 34. Right? It doesn't matter, but say you're trying to code a guessing game or some sort of yeah, just a guessing game. Right? We can branch off of this, so we can say if this is equal to 34. Right? Once again, 34 is just an arbitrary number that we chose. It can be anything. And but be careful. Make sure you use a double equal sign. Right? Once again, a single equal sign will assign the right to the left. So using two equal sign will properly compare, meaning that this will return a true or false result. Okay, for now, I'm just going to print out that's right. Okay. And let's run this. So I'm going to press play. Okay, it didn't print anything because our widget's value is not 34 yet, right? But when we make it 34 and then rerun this cell, it should say that's right. Right, let me change numbers a bit. Let's say 100, right? 100, rerun this cell, print nothing. Right? So people cool with this so far? We're branching based off of this widget's value. Okay. We're gonna build upon this in just a bit. Right? Later on, we're just gonna improve this into a guessing game where it's gonna be like, oh, the number was too small, or oh no, the number is too big. Right, so we'll do that later. But I just want to make sure folks are okay with if statements for now. Okay. Let's see. There are a lot of conditions we can represent. And so far, we've really just talked about numbers and strings. All right, so here, I'm going to bring back the terminal and just go through multiple conditions that we can represent. Once again, this is a recap on week 2. Right, week 2, we covered some stuff on Boolean conditions. Right, so you might want to revisit the 4th lesson on operators. Right, basically, in the operators on this last 5, we're going to be using these relational operators that compare things. Right, for example, we can compare less than or equal to. Right, so let me bring up a terminal real quick. Okay. Bring up a Python terminal. Now, let me just hard code a number. Let me just say number is equal to 50. Right? It doesn't matter. I'm just hard coding a number and just going to do some conditions. So one condition we can write is over here, right? Less than or equal to is number less than or equal to 34. Right? No, it's not. Right? We can check for divisibility as well. Like, how do we check if a number was even? So number can be anything. How do we check if it's even? You might remember the modulus operator. Right? Folks remember the modulus gives us the remainder of division. So we could say if there's no remainder from dividing by 2, it's even. Right? So this is saying, hey, is the number divisible by 2? Right? Because this gives us a remainder, right? And the remainder is either going to be 0 or 1. So this is true, right? Because our number is 50, right? This is an even number, right? But if our number is like 51, so I'm just going to hard code number is equal to 51, right? Is it, what's the remainder now, right? That number mod 2, or the remainder is 1, meaning that it's not going to be equal to 0. So this gives us false. Folks might be wondering what's the use in telling whether or not a number is even. I mean, one use would be to implement a 50-50 decision, right? Like you could generate a random number and check if it's even or odd. And that kind of brings us to a 50-50 scenario, right? Like let's just say I generate a random number. Like I'm just going to type in something random, right? So boom, random number. Okay, is this divisible by 2? Yes, it is true. Right, but then another number. Boom, another number. Is this divisible by 2? No, it's not. Right, so yeah, this is good for programming probabilistic outcomes. Like if folks are simulating some sort of program that has a chance of branching off into different places, then yeah, you can use this modulus. Right? Like if we wanted to make something 1/3 chance of happening, right? What would we modify it by? This would be 3. Right? That's how we would program a 1/3 chance of something happening, right? Because a random number can have a 1/3 chance of being divisible. All right, so hopefully people are cool with this, the modulus. Okay. We've been dealing with numbers. We can do stuff with strings as well, right? Like here, let me just hard code another variable. I'm just going to say course. I'm just going to hard code a string here, right? Our course is called Python Programming for Everyone. Okay, zoom out a bit. Okay, hard code a string. All right, and we can check if a string exists in another string. So this is an operator that we really haven't covered yet, but there is a keyword in. That this tells us whether or not the left substring is inside of this other string. So we could say is Python in course? Right, this is a condition that turns out to be true. All right, but let me do a lowercase p. Lowercase p is this false? No. Right, basically, there's case sensitivity here. All right, people cool with conditions so far? Okay. Okay, let's expand on the number widget and move on to the lab. Okay, so far all our number widget decisions let us do is a plain if statement. Right, we only implemented one branch. Right, let's add another branch. Right, basically, if the first one is false, then it needs to go to a different outcome. So let's get that. So far we just have this, the correct outcome, but we can use an else. Right, once again, an else is typically representing everything that's false. Right, if the earlier branches are false, then this last one will happen. And so I'm just gonna do the incorrect scenario here, like guess again. Okay, let's run this. So I'll press play. Yeah, it says guess again, right? Because our number widget is at 100. So that's not right. So let me go to 50. All right, 50 and rerun this cell. Guess again, right, we're not there yet. But when we finally go 34, right, press play here, it should say that's right. Okay. People cool with this so far? If statements and the else. Oh. Yeah, good question. This 34 is just an arbitrary number. Oh, should this drop down bar be printing anything? No, no. This drop down bar is connecting to the cell down here. So you got to press play on this bottom cell in order to see the result. Let's see. It keeps generating 0. Hold on, let me see. Wait, can you scroll down? Wait, scroll up a bit. Keep scrolling up. Oh yeah, so the widget is right here. Yeah. And what is this printing? Oh, okay. Okay, so all right. If just to reiterate, these two cells are connected. It's working now. Okay. Okay. Cool. Yeah. So these two cells are connected, right? The first one is displaying a widget, and then the second cell here is branching based off of this widget's value. So yeah, you got to run them. You got to run the second one. Right? You don't have to rerun this first one because the widget already updates when we choose a different number. So you just have to run this one, and it'll change based off what value is here. All right, people cool with this so far? Oh yeah, where is this description coming from? So let's see. We should probably look at the number widget. Right? Where was number widget declared? It was declared all the way up here. Now, you don't have to worry about the widgets too much, but the number widget is declared as a text box. Yeah, good question. Okay, we have enough to get the first part of the lab done. So let's spend like 15 minutes doing this first part. Here, let's go to the lab. So I'm going to switch to the lab over here. There are 3 parts here. All right, let's get part 1 done together. These first 2 cells are hard-coded variables. If folks can go ahead and update them, please do, because the next cells will rely on these variables. Right? Like, so here, there's a string, Python program for everyone. There's another one here, and an instructor is Mike. By the way, Mike is the original author for these notebooks. So that's why you might be seeing his name, right? Mike Matera. I think some folks here have had a class with him before. Here are 3 other variables. If folks can go ahead and update these, right? Like first name, I'm just gonna put Andrew here. Right, birth year, I'm just gonna put in 1996. Favorite number, you can put up whatever favorite number you want. Basically, these the future cells will rely on these variables. Right, these next cells are going to ask us to implement different outcomes based off of these variables. Okay, let's spend 15 minutes working on this, and then we're going to jump back into here. All right. Once again, if you're on the recording, please try it out yourself before seeing the solution. Okay, let's give 15 minutes. I'm going to pause the recording here too. Cool. Hopefully people got a chance to try out the lab. So here, let's try it out together. The first one here asks us to write a branch, right, that prints low if our favorite number is too low. Right? So here is saying print low if your favorite number is less than 100. Right? So the condition we want to represent here is favorite number less than 100. Right? So the syntax of an if statement, right? I saw folks kind of struggled on the syntax a bit, but the syntax of it goes if some condition, right? A condition is something that evaluates true or false, and then a colon, right? And then everything underneath would be indented. Basically, if you indent it, it belongs in the outcome. So let's apply that here, right? The condition is favorite number is less than 100, and then colon. And once again, indents are important. Right? If we don't indent, it technically doesn't belong in the if statement body. So make sure there's an indent here, and we're just gonna print low. Right, there's one statement in here. Okay, let me run this cell. So yeah, print low, because my favorite number is 0. Okay, and once again, you can try out different things too, right? Like, let's say my favorite number was 200. Right, I'm just gonna rerun this cell so I can load the variables back in. So rerun this, and it shouldn't print anything here anymore. Right, so yeah, I just ran this cell. It doesn't print anything because a favorite number is not less than 100, right? This condition becomes false. Okay, next one asks us to print snakes if the course has the substring Python. So we saw a tiny sneak peek on this earlier. You can see this on a lesson as well, but there is a in operator, right? Basically, the in operator tells whether or not something is within a bigger thing. It's kind of like a search, right? You can think of this as a searching condition, right? It's searching for Python in this course, right? And if it does successfully search it, then it returns true. So let's apply that. So the condition here is if Python is in course. All right, so print snakes. Yeah, there we go. And then let me run this. Yep, it prints snakes. Right? And that makes sense because Python is found in this string. Okay, let's see. Some folks were using the double equal sign here. This one is not really representing the correct condition, right? This double equal sign is comparing if the left side is equal to the right. Right, so this is going to be false because course is a much bigger string. So we want to use the in so we can search it. Okay, next one, there's multiple ways I'm doing this. Is asking us to do the opposite of this previous one. Right, there's so many different ways we can do this. I think some people use else statements. I think some people just copy and pasted this and then maybe did like an else, right? Print no snakes. Right, some people might have done this, and it's going to print snakes here because the first one is true. Right? Since the first one is true, this else one doesn't happen. Right, but here, let's test the second branch. Right, let me just change this course title real quick. So I'm going to scroll up and change the course title. Right, let's say this is C++. C++ programming for everyone. Right, I'm going to rerun this cell so our string is brand new. Okay, and now I'm going to rerun this one right here. It should print no snakes. So let me press play. Oh yeah, printed no snakes because right, the course title changed. So Python is not in here. Right, so this becomes false, meaning that the else body will capture it. Okay, another way of doing this, we can actually just copy this and negate the condition. Right, so there is, so I just copied the upper cell. We can put like a negative sign here, right? Once again, I just highlighted the, here, let me highlight this, right? This is a condition that returns true or false. We can negate it, right? There's a negation operator called not. right? So we could say if not Python in course, then print no snakes. Right? This works because we grab this condition, right? This condition is false, right? It's false, but then this not will negate it, right? So what is not false? Right? Not false is true. So this whole condition becomes true, meaning we're gonna execute the body. Right? Pretty cool, right? Yeah, exactly. Yeah, you can represent this logic however you want.
So it's no longer instead of like having two of it else like at the bottom, like when you put like Python, it will show snakes, right? And at the bottom, if not, it will show at the bottom just snakes, right?
Yeah, same thing.
With the double line, I can show you the example right
Uh-huh.
here. It wasn't like the other lesson. Something like that. Like
Oh yeah, same logic.
oh, okay. I'll probably take a look at the replay how it was done.
Okay. Yeah, if anything, it's more like so here. Let me bring up the previous cell. All right. So earlier we saw an if and else statement. Yeah. So earlier we saw this one right here. If Python in course, then print snake, then else print no snakes. Right, so in this scenario, this else statement is the same as this one right here. Right, so we can, instead of an else, you can actually just use this right here. Right, so here, let me do another one. So these two are equivalent. Let me change this. If right, this second one, we can just say else. I mean, if not Python in course. Right, so these two cells are the same, because right, this else captures the false version of the earlier one. Right. Okay, well, that makes sense because it's false, right? So someone said that there wasn't printing no snakes, right? Which makes sense because they probably didn't change this course title, right? So if you change the course title, then yeah, it's all good. You can change it to whatever you want. I mean, you don't have to, but yeah, based off what you change it to. Oh yeah, Joe. Yeah, exactly. We're just changing the initial variables. Yeah. Did you get that, George? I changed this over here.
Oh, okay.
Yeah. My bad. I kind of just snuck that in really fast. Okay. Cool. A good clarification, though. Okay, this one, next one, print same if our first name is the same as the instructor. Right, so this one is pretty much asking us for a string comparison. Right, it's asking us to compare two strings and tell whether or not they're the same. So here it's saying use these two variables. So the condition is if they're both equal to each other. Right, if the instructor is equal to a first name, then we're going to represent this print statement, print same. So let me press play here. Doesn't print anything. Right? It doesn't print anything, which makes sense because this condition is false. Right? Let me look at the initial variables. So instructor and the first name, scrolling up a bit. Right? See, these two are not equal to each other. So that's why they're false. Right? But if I do change this instructor, right, I'm just going to change this to Andrew. I am the instructor for this class. Then let me rerun this one. Right, so those strings are now equal, meaning that this condition should be true now. So it's going to print same. Okay. I hope people are cool with this. All we're really doing is comparing variables inside of conditions. Okay. This next one is asking us to use some numbers. All right, it's saying print vote if we are 18 or over. Right, so we could use the year and the birth year. Right, so we do have two variables. Right, so I'm going to scroll up a bit. Oh, hold on. Let me see. Someone in Zoom chat. See, Joe, for the number 3 no snakes question, might be better if we search for a different string other than Python. Oh, yeah. Yeah, that's a good point. Yeah, for number 3, it might be better to represent for a different string. Like, yeah, but this question specifically says if it doesn't contain Python. Right? So if we say something like, let's see, if we say something like, if not like C++ or something else, just something else. Right? This is not necessarily going to be true if it doesn't contain the word Python. So we're specifying Python just because the question asked it. Okay. Okay, let's do the voter one. So we have two variables which we can use to calculate the age. Right, so this is saying use these two variables. Right, I'm going to scroll up to see what those are. Right, they're just hard-coded numbers. Right, we have the current year equal to 2020. Here, let me change this to 2025. And my birth year is 1996. Right, so basically, we can use these two variables to calculate an age and tell us to vote. Right, so we could do it right here, right? You can say age, right? Declare a new variable. I'm gonna declare it equal to year minus birth year. These are just two numbers. Right, so this is gonna give us some number, and we can use that age variable to branch into this outcome. So the condition here is whether or not we're 18 years or older. Right? So if age is greater than or equal to, right, 18, then we're going to branch off into this print statement of vote. All right, print. And let me just do another one just so folks are aware of this indent. All right, I'm going to do another print statement. You are old enough. All right, I just put two print statements here so folks are aware that indents define the body of the if statement. And yeah, it says vote, you are old enough. Okay. Oh yeah, and then Joe in the Zoom chat. Yeah, you don't have to declare this age variable. Right? You can just put the subtraction in here instead. Right? So instead of declaring the age variable, you can just do subtraction here. Okay, so it's the same thing. Same thing. I think it's arguably a little more readable if we declare this variable though. Okay, but back to the indents. Right? Indents do matter. Right? Like, let's say I didn't indent this second print statement. Right? So this is actually pretty important stuff because some folks might not indent things. Right? Let's say I didn't indent this. Right? And let me just press play. Right? So I just pressed play and it says vote. You're old enough. Okay, that makes sense. But check this out. Right? Let me just change this age variable. Right? You know how to do this. Let me make it like 15. Right? Let me say age is 15. We are not old enough to vote. Right? But when I press play, it's going to say you are old enough. I hope folks see what's happening here. The pitfall here. We didn't indent the print statement, meaning that this happens regardless. Right? This print statement happens no matter what, because it's not inside of this if statement. Right? So this is false. We don't print vote. But then this is outside. So people kind of see the importance of indents now. Right? If we indent this, it means it belongs inside the outcome. So when we press play, it now doesn't print anything. Right? Age is 15, this is false. Okay, hopefully people are cool with this so far. Okay, and yeah, I am old enough. Can not indenting be a form of commenting out something? Uh, it's kind of like the opposite of that, because if you didn't indent it, right, it means it's going to happen regardless. So you're not really disabling this line of code. It's happening regardless. Okay, this couple more, and then we're gonna move on to some more stuff. So this one's asking us to check the first character in a string. Right, it's saying print yes if your name starts with the letter L, right, and then no otherwise. So we're gonna do some if and then an else. Right, and the hint here is Google a function called Python string starts with. Right, you can Google this later. There's pretty much a function that allows us to check the first letter. Right, so this is, we're checking if the first name starts with the letter L. Right, once again, you can Google this later. This is a string function. Right, this is a, here, I'll Google this right now. So Python string starts with. Okay, Python string starts with. Okay, cool. So let's see. Okay, yeah, there's a bunch of things we can look at. We can look at this AI generated answer. I would prefer looking at primary documentation. So if you want to look up primary documentation, you can look up Python string functions. And then the primary documentation is right here on the docs.python.org. Right, there is a function called starts with. Right, and this function returns a Boolean. Right? It returns true if the string does start with the argument, and false otherwise. So we're just using this function here, right here. Right? This is a condition that returns true or false. Right, if it's true, we're just going to say yes. Print yes. And then it says no otherwise. So I'm just going to say else, right? You can do it in else. Print no. Okay, this should print no because my first name starts with an A, so it does print no. Okay. You don't have to use an else statement. You can actually be more explicit with this. Or you can actually just you reuse this if statement. Or you can actually just say if not starts with L. Right. It's the same thing as the else. Right. So here, let me just make another cell so folks are aware of this. Okay, so both of these are logically equivalent. They're logically equivalent. Right. The second one's a little tricky to read. Right. Just to kind of split it up. Right. This condition returns true or false. Right. In this case, my name doesn't start with L, so this is false. Right. So false, but then it says not. Right. So what is not false? Right. Not false is true. So this whole condition becomes true, meaning we're going to print no. Right. It's the same as this bottom one. Logically the same. This second one is actually more efficient, though. It's yeah. If you're getting a syntax error, you might have to check your characters or something. It's probably just a small typo again. So let me take a look. So expected colon starts with L. First name starts with L. Oh, you did. Can you rerun it? Oh, this cell up here. Okay, yeah, you're good. Yeah, I think you just had to rerun the cell. Hope you're all good, Terrace. I think you were accidentally running another cell. Yeah. Okay, let's do one more, and we're gonna move on to some fancier branches. All right. This one is asking us to print millennial if our birth year is between a certain range. All right, so let's implement that. The condition here, this is a little, we can chain we can chain relational operators. Right? Relational operators are like less than, greater than, equal. Right? We can chain them. We can represent if the birth year is between two different numbers. Right? So we can say if it is greater than or equal to 1981, right? And then the right side of it, we can say if it is less than or equal to 1996. Right? So that's the condition that we're representing, right? It's saying if it's between those 2 years, and it's including them because we are using the equal sign. Right? So that's handling this first branch. Right? Print millennial if this is true. Right? So I'm going to print millennial here. And there we go. Yeah, print millennial. Right. There are a couple other branches that we should implement as well. Like this one says print older if we are older and younger if we are younger. So we got to do two more branches. Right. So we could do if. Let's do the older one. Right. Older one means that our birth year is less than 1981. Right. So we could say if birth year is less than 1981, then older. Right. Older. And then the younger one, if birth year is greater than 1996, right? It means we are younger. Right? And it still prints millennial because only the first one is true. Oh yes, Joe in the Zoom chat did one if statement and used an else if. Yeah, that works as well. We actually haven't covered else ifs, but yeah, it is totally possible to actually connect these. So just as a sneak peek into what else ifs are, uh, the, this snippet of code is actually kind of inefficient. Right? Why is it inefficient? So this first line of code is being executed. Right? It's comparing this. Right? So this is true, right? Because I am born in 1996, so this is true. Right? But it's inefficient because we're going to check these other ones as well. Right? So the program is going to go here and say, hey, are we less than 1981? Right? We actually don't need to check this. Right? There's no need to because the first one is very true. Right? If the first one is already true, there's really no reason to compare these next numbers. So as a sneak peek into else ifs, these are connecting this into three branches. Right? Technically, we have three trees here. Right? We have three trees, but we can connect them with an else if. Right? So this is a sneak peek. Right? Elif. Right? Elif is short for else if. Basically, we're connecting them, and now we have one tree with three branches. This is more efficient because if the first one is true, it doesn't bother checking the next ones at all. Right? So this does give us the same result, but it's more efficient. Right? So this is true. It's going to print millennial, and then it's going to go to the bottom of the tree. Right? None of this is going to be checked at all. Right? Contrasted to the earlier one. So here, let me bring it back to the earlier one. So earlier we used three if statements. Right? So this first one is this is technically 3 separate trees. 3 separate trees. Right, and this one is a one tree with 3 branches. All right, once again, the first one is not as efficient because all these 3 conditions are being checked. So there's some redundancies here. But this next one is more efficient because if the earlier one is true, the next ones won't happen. Let's see. Let's see. Someone in the Zoom chat says, here, let me copy and paste this. Yeah, someone in the Zoom chat had this solution here. So right here. Yeah, this looks logically the same as well. Right? It's pretty much the same as up here, just in a different order. Right. So this one is saying if the first one is, so let me see if it works. Okay, it does print millennial, right? Which makes sense because this is false. Right? This is false, so it's gonna move on to the next ones. Right? This is false again. So then this else will capture everything because everything earlier was false. Yeah, this does work, Joe. It is logically the same.
So you're saying that
Yeah, I'm saying that both of these are the same right here. They're the same logic. Yeah, they're the same logic. The second one is more efficient. Yeah. The second one is more efficient because this first one, we're using 3 separate if statements. Right, so when we're using if statements that are disconnected, we're doing some redundant checking. Right? We're checking this condition. Right? And then if this condition is true, there's no need to check these other conditions. Right? But it's going to check it regardless because they're 3 separate trees. This next one are connected. Once again, we haven't covered else ifs, but this is a sneak peek, right? The else ifs connect them all. Yeah, but basically the takeaway here is if an earlier one is true, the next ones won't be checked at all. Yeah. Thanks for bringing that up. So you know what? Let's move on to else ifs, right? And we should be able to do the part 2 later. Okay, so let's go back to the lesson. We got all the way down to asking multiple questions with elif or else if. Okay, let's upgrade our guessing game. So going back a bit, right, we had a guessing game that tells us whether or not we guessed the number correctly. Right? In this case, we just hard-coded at 34. Right? And once again, this guessing game relies on this widget. Right? So all we really have right now are 2 outcomes. Right? One outcome that represents a correct one and another one that represents an incorrect one. Right? So let's upgrade this to give the user some hints. Like maybe we could tell them, oh, the guess was too low. Or we could also tell them, oh, the guess was too high. All right, so we're going to have to implement two more outcomes, right? One that's lower and one that's higher. So that's where the else if comes into play. All right, so here, let me copy this first branch over. And let me rerun this cell to display the number widget. All right, so here, let's add in some other branches. Like if this first one is true, if it's false, then we should give them some hints. All right, so this is the part where we use some else ifs, right? Like we can represent too low, right? So we could say number widget dot value is less than 34, then we can give them a hint, too low. Okay. Cool. And then we could go the other one, right? The other one, we can actually use an else if as well. If the number widget dot value is greater than 34, then we can print too high. And we're just giving them some hints, meaning if the first one is false, then we're gonna cascade down and check the next ones. Okay, so let's test this. So I'm gonna press play Okay, cool. It says too high. All right. Yeah, because 44 is greater than 34. Right, so let me choose a smaller number, like 13. So I just changed it to 13. I'm going to rerun this cell now. So this is going to say too low, right, which makes sense because 13 is below 34. Again, finally, if I make it 34 up here and then press play. Okay, press play. It says that's correct. Okay, cool. So we just kind of upgraded the guessing game a bit. Okay, and there's a few different ways we can represent the same exact logic. We don't have to use an else if on the last branch. Right? We can actually just say an else. Right? So this is going to be the same as over here. Right? So this snippet, these two are the same. Right? I think the second one, I prefer the second one because it's more explicit about the conditions. Right? But typically you can use an else at the very last branch. Right? The else will only happen if the earlier ones were false. Okay. Let's see. I do want to point out a common mistake that might happen a lot. So here, let me convert this to an else, this last one. Right? We don't have to check the condition. We can just say else right here. Right, so it's going to give us the same exact thing. Right? Basically, this first one is true, so the next ones won't happen. A common pitfall, people might do separate if statements. Right? Like, what if we didn't use an elif here? Right? So check this out. If I use an if statement here, right, we actually disconnected the tree. It's a little hard to see right now. Okay, so here, let me undo this. So I just undid it. Right, this is one tree with 3 branches. Right, but if I remove this second else if, right, if I make it an if statement only, right, it's actually kind of hard to see, but we have 2 trees now. The 2 trees is right here. Right, this first one is disconnected from the second one. Right, so this is actually going to give us an incorrect answer. Right, so I'm going to press play here. Right, I'll just press play. Right, so our number is 34. This should be correct, right? But it's saying that's right. Then it's saying too high. Right, so the pitfall here is we accidentally disconnected the tree, meaning that they're separate. Right, this one is true, but since they're separate trees, this one is being checked. Right, this if statement is being checked. This is false, so we're going to print too high. Why is it generating too low? So yours is saying too low? Yeah, so these rely on the number widget. So you might have to go up to this number widget and kind of play around with it. Oh, okay. Well, actually, for 100, it should say too high. Yeah, yeah. Because here, let me connect these trees back. But anyways, hopefully people are cool with this. Right? We just disconnected the tree. It should have been connected. Yeah, and Terrence, you might want to flip your signs or something, but 100 is too high because 100 is above 34. All right. Hopefully people are getting a sense of the difference between if statements and else ifs. It's going to take a bit to get used to. All right. Okay. Let's add one more outcome. Right? Like so far we just have 3 of them. Right? Let's say we were to add another outcome where they are way too off. Right? Like let's say someone chose like 2000. Right? It doesn't matter. Basically we want to tell them, "Oh, you're way too off." Right? So 2000, this is going to print too high. Right? But what if we wanted to do some bounce checking? Like say, "Oh, that is way too high," or "That is way too low." Right? So let's let's add one more branch to improve this. Okay, scrolling down a bit, I'm gonna rerun this display, right? And then I'm just gonna paste over the previous implementation. Okay, we want to add in one more, right? Because right now it says too high, right? What if we wanted to say you're way off, right? So one way we could represent that is with this branch, right? Where maybe the second branch, I could say something like else if you're way off, right? So we can define way off by saying, oh, they're like less than 1, right? Or, right? Oh, we haven't covered this or yet, but let's talk about it. But this or allows us to chain two conditions. So we could say, oh, if the number is way too low, or if it's way too high, right? I'm just going to define as way too high as 100, right? Then we could say you are way off. You are way off. Right, so 2000 is way off, so it's going to print you are way off. Right, but if we get closer to the answer, like 50, right? 50 is within these range, so 50 is going to print too high, right? Because these first two are false, right? And then this next one is false as well, so we're going to print out this last one. Okay, the sneak peek here is actually this or operator. Right? Or allows us to combine two conditions. Right? So we actually have two conditions here, this left one and this right one. That the or basically tells us if any of them are true, then the whole thing is true. Right? So once again, only one of these conditions need to be true for the whole condition to be true. All right, hopefully people are cool with that. Ors. We'll talk about ands later. Okay. So yeah, let's keep testing this. Like if I go -50, right? -50 is way off, right? So just kind of tracing through that. -50, this is false, meaning we're gonna check the next ones, right? This one becomes true, right? It becomes true because this first condition is true. Right? Once again, only one side needs to be true for this whole condition to be true. So then it says you are way off. Meaning we're not going to check these next ones. These next ones are totally ignored because the earlier one was true. Okay. People cool with this so far? The order does matter. If we were to change the order of these second and third branches, all right, so here, let me change the order of this. Here's the second branch, and here's the third branch. Right? What do you think is going to happen if I swap them? So here, let me swap them. So I'm going to go cut this, and then paste it right here. All right, I just swapped the order of them. All right, let's see what's going to happen. So before I press play, all right, -50. Right, is this true? No, it's not. Is this true? Yes. So it's going to print too low, and then ignore these next ones. All right, so here, let me press play. Okay, there it is. I press play. It says too low. All right, so the order doesn't matter. If we intended to print this one out, typically you want to put the more constraining branches towards the earlier one. Right? This is a more constraining branch, so it would make more sense to check this one earlier, right? Because -50 should have printed you're way off. Are people cool with that? The ordering of these branches do matter. Okay. The ordering of the branches matter when they're connected. So I'm going to bring it back over here. Okay. Just change the order again, and this one should print you're way off, right? Because the earlier one is true, so it's not going to check the next ones at all. All right, hopefully people are cool with this. Okay. We just covered else ifs. We should have enough to get the part 2 done in the lab. So here, let's switch over to part 2 of the lab and help folks out get started on this. All right, the part 2 is really just asking us to write some if with else ifs. First one is asking us to print out your certain generation. I think this might be a diverse class, so people might be in different generations. So yeah, see if you can implement these 4 branches. You can do it however you want. So I'll let folks do this. I'm just going to put a comment here to do implement 4 branches. Right, that's really what it's asking to do. Okay. Let's see. Was after Gen Z? Good question. Yeah, what's after Gen Z?
I believe it's Gen Alpha.
Gen Alpha. Cool, cool. Yeah, Gen Alpha. Interesting. That would be the middle schoolers, right? Yeah. Yeah, so number 1, folks should be able to try that out. These next ones are a little trickier, actually. Number 2 and number 3. Let's see. Here, I'll help folks get started on the next ones because it's asking us to use a widget. Widgets aren't that important for us to implement, so I will do it for you. Pretty much this second part asks us to use a widget to input a word, right? And then based off of that widget's value, right, we're going to branch into different scenarios. Right, so it's kind of like the guessing game earlier. The guessing game earlier used a widget to input a number, but now we're going to input a string and branch off into different scenarios. All right, so here, I'll help folks get started on this widget. Once again, widgets aren't too important, so I hope folks get this. All right, I'm going to make a word widget and then set it equal to a text box. All right, so I'm going to use the. Oh, you know what? We need to import the IPy widgets. Okay, we need to import that because this word widget will pull from that library. All right, so I'm going to get a word widget and say it's equal to widgets dot. I'm going to use a text box. Right? If folks are wondering what type of widgets you can use, you can look it up. Right? You can Google up IPy widgets list, and there are lots of widgets we can use, like for strings. For string widgets, we can use something called a text box. Right? But basically, a text box allows us to type a string in. Okay, so I'm going to use a text box. So text, and yeah, I'm going to keep this blank. I'm going to keep the description blank just to be very simple. So here, let me display the word widget real quick just to make sure we're on the right track. Okay, there we go. I just displayed the word widget. So there we go. We can type in anything here, right? Like I'm just going to type in something. Right? Basically, the goal of this exercise is to use the word widget's value and branch off into different scenarios. Right? Like here, let me make a new cell. Right? So I'm gonna make a new cell which is intended to implement these 5 branches. And once again, these 5 branches should rely on this word widget's value. So you will be using something called word widget.value. Right? You can look at the previous lesson. Right? Basically, it has a attribute. So you can basically this first branch, right? If the word starts with X or Y, then we can print this. Right? So we can represent that. we can say if a word widget dot value. All right, once again, a word widget dot value is this string right here. All right, this string becomes this variable. So the first branch, we can say, oh, if that word starts with X or it starts with Y, then we can print this string out. All right, so here, let's represent that. Before you type this out, I'm actually going to make it more readable, right? Because you could say if this string, right, dot starts with X, right? This does work, and you can say or it starts with Y, right? So I'm going to compound two conditions and then colon, right? So this is saying, oh, if the string, and once again, I just highlighted the string. If this whole string starts with X, or the whole string starts with Y, then we can print this string here. I'm just going to copy this. All right, copy this string. So print that. All right, so here, let me run this. So there we go. It's not going to print anything because this doesn't start with X or Y, right? But if I do like yellow, right, yellow, and then rerun this over here, right, it prints the outcome. Okay, so this is actually can be written to be easier to read, right? Like maybe we could capture the word widget's value into some variable. Right? It'll make it more easier to read. Like we could say word is equal to a word widget dot value. So word is equal to word widget dot value. All right, this is saying declare a string variable which is going to store this text. Right, so instead of using the value here, right, we can just use word, right, because that word already represents this value. Right, same with right here. So word. Right, so this is a little more easier to read. Okay, so let me run this. Huh? Yeah, it's easier to read because earlier our conditions were kind of big, right? So I just undid these changes. You see how this is like, it's arguably harder to read. Word widget dot value. I mean, I can read this fine, but if you store it in this word, then this can be simplified, right? So this is the same as saying word. Oh, I typed this in. So this yellow, you can type in whatever, right? Like if I type in Andrew here, right, and then rerun this, it's not going to print anything, right? Which makes sense because this first one is, yeah, exactly. Yeah, it doesn't start with X or a Y. Right, but yeah, so there, you do have to rerun this second cell. It's not going to update automatically because we didn't program an interaction, right? So basically, whenever you update this cell, you have to manually press play. Right? You have to manually press play because we never used the interact function. Right? Once again, widgets aren't too important, but basically you have to press play yourself. Is it a capital Y? Let me see. Yeah, let's see. It starts with Y. Oh, nothing's typed here. So yeah, yeah. Yellow, and rerun this bottom one. Oh, okay. Okay. Yeah, I'm not sure what was happening there. I think it was just the order of the cells that was being run. Huh. Oh yeah, Yeah, you don't have to rerun this first cell. Yeah, no, this second one. So the to do here is to implement the other branches. Right, there are 4 other branches to implement. So I'm gonna put a to do here for folks. Implement the 4 other branches. Okay, and you can do this however you want, but the intended result was to use some else ifs. All right. Let's see. Let me think of a hint for this third one. The program. Okay. Yep. I hope folks get started on the last question in part 2. This one is asking us to create 2 widgets that draws a specific shape. All right, so it's going to be using the turtle, but it's asking us to implement one widget, a pull down widget. Right, a pull down widget lets us have choices. And then it's asking us to implement another widget, a numerical one. Right, we can use whatever. I would prefer a slider here. All right, so here, let's do the first one, a pull down. Right, if you're curious what a pull down is, let me look at the documentation. Right, so a pull down is a selection widget, or drop down. This is a synonym. So we could use a drop down in order to represent multiple choices. Okay, so I'm gonna go ahead and declare a pull down widget. I'm gonna say shape widget, right? Because this pull down represents whether or not we want to draw a triangle or a square. Right, so I'm gonna set this equal to the drop down. All right, and let me give it 2 choices. So the way we do that is by putting in an argument. Let's see, options. All right, so I'm going to use options equal to a list of choices. Right, in this case, we just have 2 choices: triangle and a square. And let's see. Oh, I got a typo here. So I just tried running it. It needs to be a plural. IPy widgets with an S. Okay, there we go. No compile errors here. I mean syntax errors. So we can go ahead and display that shape widget. So I'm going to do a display the shape widget. Okay, there we go. So there is our drop-down menu that consists of 2 shapes. Now we can choose whatever. All right. Oh, let's talk about the value in a bit. But we need to implement one more widget that represents the length that we're trying to draw. Right, and it is asking us for a numerical widget. There's multiple number of widgets you can use. I'll probably stick with a slider. So just looking at the numeric widget, I'll probably just stick with the first one, like an integer, right? Which basically lets us drag a slider. Right? There's other ones too, like you can use a vertical one. Let's see, what else? Yeah, you can use this too. Yeah, loading bar is a widget, number widget. Let's see. I'm gonna stick with a slider though, just because it's easier. So int slider. So let me call this a length widget. So I'm declaring a variable called length widget and setting it equal to the int slider. Int slider. Okay. Let me see. Let me specify a specific range here. Once again, you don't really have to know how to use widgets. It's not too important. Let me see. Let me set the min and the max. So let me go min is equal to like 20 and max is equal to like 200. Now you don't really have to know this. This is just specifying the left bound and the right bound. So let me display this. Display length widget. There we go. Yeah, see the bounds are from 20 to 200. Okay, once again, this is asking us to use the values of these two widgets and display something. Okay, so I'm actually gonna make another cell to implement the branches, right? Just to keep them separate. So I'm gonna press plus here, make another cell, right? The intended result is this cell will grab these widgets values, right? Like if this is a triangle, then we need to draw a triangle, right? So you can actually represent that here, right? So you could say if the shape widget's value is equal to a triangle, right, then we can draw the triangle. So I'm just going to do a dummy print statement here. It's not going to draw a triangle. I'm just going to say drawing triangle. All right, so there we go, drawing triangle. And here, let me test this real quick. So I'm going to run this. And yeah, you see it says drawing triangle. Okay, but if I change it to square, it doesn't print anything yet because we didn't implement that other branch. Right here, let me help folks get started on this other branch, the square. Right, the shape widget value is equal to square. Then we're gonna, oh, else if, my bad, elif. Then we're going to draw a square. So let's test that. There we go. I just ran it. So when we update these drop downs, it'll change the output accordingly. All right, so the to do here is to implement the branches. Implement the branches to draw certain shapes. Right, and those shapes will rely on this drop-down menu and the int slider. Right, basically, if we change this slider, right, this is the length widget's value. Right, so you're gonna have to figure that out. Let's see. Someone in the Zoom chat says, or else just drawing square because it's the only other selection. Oh, let's see. Yeah, that's a good point. Yeah, someone in the Zoom chat says that this is technically unnecessary, right? Like you can just say this is else, print, draw a square, right? But I actually prefer being explicit because it'll let us upgrade the program in the future, right? Like what if we wanted to add in more options, like a trapezoid or a circle? In that case, it might be more appropriate to be more explicit about the shape values widget. So yeah, good point though, Joe. Once again, it's the same as putting this in an else. Yeah, same thing. Okay, here I'll help folks get started on this because you have to. I think you have to import something. We never imported the turtle, so let me copy and paste the import statement for the turtle. I think it's somewhere in our previous lesson. Okay, here it is. So import this. Okay, let me import turtle, and then let me help folks get started on it. There's going to be a tu.new. Okay. Okay, there we go. There's a turtle. And just to help folks get started more, we are using two widgets, right? We are going to use the length widget's value. So one way you can access that is with dot value, right? Like here, let me just make these print statements more explicit, right? So let me make an f string and say drawing triangle of size length. Right, that length comes from the widget.value. Right, and let me do the same with a string, the square, I mean. Round square of size length widget.value. Okay, so here, let me play this real quick. So the print statements are underneath the turtle. So right here, yeah, see, it says drawing triangle of size 76, right? That's because we our length is at 76, right? But if we change it to like 150 and rerun this cell, it's going to say drawing triangle of size 151. All right, so hopefully this gives folks a head start. Basically, you just want to put in some moves and turns in here. Right? You can actually reuse, you can reuse your functions from a previous project. It should be a little smoother. Wait, why did I do the what function? Oh, I use an f string just to visualize the widget's value. Yeah, so I just want to show. Yeah, yeah. So it's going to print out whatever we put here. All right. So the length widget's value comes from this slider. So yeah, yeah. You don't have to do it. You don't have to use an f string, but I'm using an f string so folks are aware that you can access the length here because you're going to need to use this length. Right? When you're drawing the shape, right? The moves will rely on this number. Yeah, the length widget's value, exactly. I hope that makes sense. Let's see, it's a mini project, right? The point of this is just to draw a shape based off of widgets. Yeah, so number 3 says, yeah, write a program that draws a triangle or a square. Anyways, I'm trying to give folks a head start on this. Let's see, we got like 5 more minutes left in class, so let me do some concluding thoughts. I'm gonna leave these as to-dos. So see if you can get this done at home. Number 1, we want to write 4 branches to determine which generation we're in. All right, this one doesn't require any widgets. Right, it's just gonna ask you to write like 4 branches that comes from the birth year variable. And then the second one, I already helped folks get started on this. And then this third one, the shape. Okay, so for some concluding thoughts, we finished. We to try to get the first 2 parts done. All right, so part 1 we already finished. So I'm gonna collapse it. All right, part 1 we already finished. Part 2, see if you can get this done before Wednesday, because Wednesday's prereq will be relying on folks being able to use else-if statements. Right. Also on Wednesday, we're going to be giving a sneak peek into a new assignment. Right. That new assignment will involve else-if branches. Okay. As a high-level overview, hopefully folks kind of see the importance of making decisions. Right. It lets us branch off into different outcomes. Right. So once again, make sure you're comfortable with if and else statements because we're going to be writing more complex trees. Right? Like right now, all we're really doing are flat trees. Right? Flat trees meaning that it's kind of like 2 layers. But for the next, on Wednesday, we're going to be doing more complex trees, right? Where you're making decisions within decisions. Okay. So yeah, other than that, thank you all for coming. And we will finish the rest of this lesson 14 and lab 14 on Wednesday. All right, have a great day, folks.